Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X, published on February 20th, 2026, just 4 days ago. It demonstrates that specific identity representations in Stable Diffusion can be reliably navigated using only descriptive features, without using names or photos, raising the target identity hit rate from about 8% to 70% through a self-distillation loop. The paper is titled Morphological Addressing of Identity Basins in Text-to-Image Diffusion Models. And, as we'll see later, the findings on how even nonsense words can trigger specific visual concepts are really impressive. Figure 1 visualizes this concept of morphological addressing using a Venn diagram structure. It displays 4 overlapping regions, representing broad descriptors like platinum blonde, beauty mark, red lips, and 1950s glamour. Individually, these tags are too vague and contain many possible faces. However, the glowing center reveals that their intersection forms a precise identity basin, allowing the model to zero in on a specific person solely through this unique combination of features. Well, to establish a baseline, Figure 2 illustrates this using a generation from Grok. When prompted simply with the name Marilyn Monroe, the model produces an output that closely resembles an archival photograph. This indicates that the identity is heavily memorized within the latent space, almost as if the model is recalling a specific training image. It acts as a reference point for the identity basin that the researchers aim to navigate without using the name itself. Alright, Figure 4 details the actual mechanism used to trap this identity, which the authors call a self-distillation training loop. The process begins at step 1 with the morphological descriptor prompts, which feed into step 2 to generate initial images. Step 3 is crucial. Humans curate these outputs, selecting only the few that accidentally land in the correct identity basin. These synthetic successes are then used in step 4 to train a low-rank adaptation adapter, which encodes that specific identity. As the bottom panels note, this creates a feedback loop where the model teaches itself, boosting the hit rate to 70%. To make that self-distillation process concrete, Table 1 lists the exact training settings. The authors use Stable Diffusion 1.5 as the base model, configured with a LoRa rank of 32. Crucially, the final training set size is surprisingly small at just 52 images. This compact dataset, built over 4 refinement rounds, is all that was needed to anchor the identity effectively. So, Figure 5 visualizes the results of this iterative process, tracking the model's convergence over 4 stages. The top row, labeled Round 1, displays high variance where most outputs are just generic portraits, corresponding to that low 8% hit rate. Moving through the middle rows, the specific features begin to lock in as the self-distillation takes effect. By the final row at the bottom, the model has fully converged, producing consistent stylized images that capture the iconic look of the target identity. Now, Figure 8 reveals a fascinating side effect when the model is pushed away from the target identity. On the left, the base Stable Diffusion model collapses into an eldritch structural breakdown, generating a skeletal form. In contrast, the image on the right shows how the low-rank adaptation changes this failure mode. Even when conditioned to avoid the identity, the adapter exerts a coherence drag, pulling the output back into human territory. This results in an uncanny valley face that is anatomically plausible but deeply unsettling. Okay, moving to the second study, Figure 11 presents what the author calls confirmed cryptids. These are nonsense words constructed from phones themes, which are sound clusters that carry inherent meaning. The top row shows the output for the invented word snudgeoid. By combining mechanical sounds with the robotic suffix OID, the model generates consistent transformer-like figures. The middle row uses crash axe, mixing impact sounds to produce rugged off-road vehicles. Finally, the bottom row displays brewmix, where the suffix inks triggers a specific European comic style. Crucially, the model constructs these cohesive visual identities purely from the structure of the words, not from memory. Wrapping up, 2 takeaways stand out. Diffusion models organize visual concepts through deep structural features rather than just labels, and even the sound of a nonsense word can trigger consistent imagery. This suggests we can map these latent spaces precisely using linguistic patterns. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.